Hi, and welcome to this course on the Arturia Moog Modular V. This course is a sequel to the Arturia Modular V Essentials course that we have here. If you haven't already watched that, I would highly recommend checking it out, especially if you're new to this software. I've covered a lot of the basics in the Essentials course, and this course will focus exclusively on some of the advanced features on this modular software synthesizer. We're going to look at this step sequencer, the very powerful step sequencer that tons of controls in there to explore. If you didn't already know this, you can actually swap out some of the default modules with some more advanced modules. We're going to check out all of them in great detail. The Moog Modular V also has a bunch of audio effects, like the chorus and the delay, and we'll check those out as well. Alright, so let's get the ball rolling by taking a look at this sequencer, and that's coming up in the next tutorial. So let's start off this course by taking a look at the sequencer. We're going to start from scratch, so I'll open this preset browser, select template here, and choose the blank synth preset. Let's close the browser, and now let's set up a simple voice. I'll take the pulse out from this oscillator, plug it into the filter, take the filter output, and plug that into the VCA input here. Let's hear this. I'll make sure the sustain is all the way up on the VCA. Open up that cutoff. Now let's scroll down to the sequencer. So how does this sequencer work? You can see there are 3 lanes of dials over here, each dial representing the voltage value of a step. So you can think of it as 3 independent 8-step sequencers. But it can actually do much more than that. Let's set up a simple example. So let's say I want the pitch of this oscillator to be controlled by the sequencer. So right next to this keyboard control, you can select which sequencer will control this oscillator. So when I click and drag here, I see the different sequences, but it actually goes up to 4. There are 3 lanes, but the 4th lane is actually a chain mode where you can combine all the 3 lanes together as one. Let's just use S1 for now. So now we're just using this first lane. Let's set up the different CVs. And if you notice in the bottom left corner, as I click and drag, you can see the actual notes. So I'm just randomly picking different values here. Alright, so if I play right now, you'll hear that the sequencer is not running. The first step LED lights up, but it doesn't move. Now the sequencer has a sequencer trigger on option over here. And I can click here and choose what will trigger it. So by default, it's already set to keyboard trigger on. There's a sequencer off option as well, and that's set to keyboard trigger off. And you can also manually trigger these options by just clicking on the button right below. Now the reason why it seems like the sequencer is not running is because the rate of the sequencer is very, very low. So when I crank up this frequency value, now you can see it move. So we can manually turn on and off the sequencer or use the trigger input, which we've already set up. So if I hold down a note, we now hear the sequence running. And of course, in real time, we can change up some of the parameters. Now this frequency control can be MIDI synced. So now when I change this value, you can see subdivisions of your master tempo. I'll turn it back off, so now it's free running. Now instead of actually controlling this with the keyboard, we have some other options. Let's just turn this off, and I'll disable this trigger option. You can also have a next step trigger with this control. So I can pick from any of these trigger options to trigger the next step. So let's try it with the keyboard trigger. So now every time I play a note, the sequencer will advance to the next step. So like this, you can manually control the rate of the sequencer. Alright, let's disable that and turn this back to keyboard trigger on. Now you also have a manual real-time control for each step over here. So while the sequence is running, I can just hit any of these LEDs and trigger the sequence from that particular step. And for each of those steps, you can also have an external trigger option. So very extensive control there you get for the sequencer. Alright, so that was a quick introduction to using the step sequencer. In the next video, we'll check out how to make use of the other lanes in the sequencer. Now let's see how we can use the second or third sequencer lane. It's actually quite simple. Just click and drag here to switch to S2, and now we're using the second lane. I'll change up the CV values here, and now you can hear it working. Same thing for S3. Now instead of using the sequencer to control the pitch of the oscillator, let's use it to modulate the frequency on the filter. So I'll click here and switch this to S3. So now the third lane of the sequencer will control the cutoff on the filter. I'll randomize these control voltage values. So now they're no longer pitch values, but just different control voltages to change the cutoff on the filter. To hear this better, I'll turn off the oscillator sequencer control for a second. And now you can hear the cutoff being modulated by the third lane of the sequencer. Alright, I'll set that back to S1. We have a smooth option over here. So for each lane, you can smoothen out the values switches between the different steps. So if this was controlling pitch, it will sound like glide. So the same for the third lane. So now the filter cutoff will gradually switch between the different values. Might be a bit more obvious with some resonance. So you can clearly hear the difference there with and without smooth. Alright, now let's take a look at using the fourth lane, which lets you combine the three different lanes in interesting ways. So let's set that up for the oscillator pitch. So I'll switch this to S4. If I play right now, let's disable the filter cutoff modulation. So we just focus on the pitch. So it doesn't seem like it's working. It seems like only S1 is running. That's because this chain selector is set to off or manual, which means I can manually switch between the three lanes by just clicking on any of these three on switches. So as the sequencer is going through the 8 steps, it's jumping between the 3 lanes when I click on any of the 3 lane on switches. And as you've probably guessed, you also have an input control for these switches, so you can trigger it with any of these controls. Now instead of having a manual control like this, you can also set it up so it goes through the different lanes. If you click and drag over here, you get a bunch of different options. I'll scroll all the way to the very first, which is L123. So in this mode, it will linearly go through all the 3 different lanes. Let's try this other one, which is 321. So the third lane first, then the second, and then the first. We have just 1 and 2 here. One and 3. This one is 2 and 3. Next we have the C mode, which basically moves through the different columns. So each step will be on a different lane. So from my understanding of this is when it's set to C1, 2, 3, you would expect it to start with that first sequencer on the first step, second lane on the second, and third on the third, and so on and so forth. Let's see if that's what's happening. Now for that first step, we are hearing a low note, and if I change the value here, we don't hear that first value change. If I change this one, it's not that as well. But if I change this one, so it looks like it's starting from this second lane. And then it goes up. Actually, no, it goes down here. So it's going 2, 3, and then 1. So I'm not sure if that's a bug or it's supposed to run like this, but just be aware of that. So those column ones are a bit strange, but just be aware that it basically jumps between different columns. You also get the ones with just 2 lanes. Now finally you get this random mode, where it literally just randomly jumps between the different lanes for each step. So the result is you always get a different sequence. Let's add some glide. Cool, so that's how all that stuff works. There's still a lot more to cover on this sequencer, so stay tuned for more. Now at the bottom here you have this next option. So basically you get control over which next step it goes to after the sequencer plays a particular step. So right now it's going in a linear fashion, one step after the other, and the very last step's next is set to 1, so it loops back to the first step. Now of course you can change these up. So you can create a very specific directional pattern. Or you can also set it to random. So when the sequencer arrives at that step, it randomly picks any of the other steps to move on to next. Right now I'm using chain 4, which is set to random, so it's truly random in every sense. We can tone that down a bit. Maybe we can set it to L123. And in fact, let's just use lane 1 for now. So I'll set this to S1. Now here's something interesting. So you notice on step 5, it's set to go next to step 5 again. So it's basically stuck at step 5. So you might want to avoid setting a step to its own step value. I have the same problem here for step 3 as well. So now it's running through, and on that very last step, it randomly selects from any of the other steps. So that's how this next option works. I'll reset it back so it's running in a more linear fashion. Okay, so next, let's check out this repeat option. So you can choose to have a higher time value for a particular step. So for example, if I set this to 2, let's do a few more 2s here. So now those specific steps will last for twice as long. And of course, it does not have to be 2. You can change that to a longer value. So this can make the sequence a bit more interesting, rather than having every step with the same time value. So you've heard of clock dividers, you can think of this as a clock multiplier. So repeat lets you control how long the sequencer waits at a particular step. Alright, now other than using the sequencer to control the oscillator's pitch, the filter's cutoff frequency, we can use it to control some other parameters by using the sequencer control CVOut. So let's see how that works. So let's say I take this envelope out here and plug it into the filter cutoff modulation input here. And I'll set the trigger for this envelope to be the sequencer trigger. So the sequencer also outputs a trigger signal. So on every step, we get a trigger signal which can be used to trigger any other parameter. And this length dial over here controls the length of that trigger signal for each step. Alright, so let's see this in action. So even if I turn off this sequencer option, so there's no pitch modulation, you can hear how on every step of the sequence, that envelope is re-triggering because I set that up. Okay, so let's turn the pitch modulation control with the sequencer back on. Now the step sequencer is controlling the pitch of the oscillator, but on every step it's also re-triggering that envelope. can play around with the length of that trigger output. If it's too long, you won't hear it re-trigger. Though it does depend on the rate of the sequencer. So if I slow that down, now I can make this length longer. Now given in this scenario, we're not really using the length for anything because it's just triggering the envelope. But let's see what else we can do with this. Let's set up some repeats for this sequence. So now we have a sequence with irregular lengths for each step, almost each step. But if I turn on this LED, for that first step we're getting 2 triggers. If I enable the LED on this one, we get 3 trigger outputs and 4 on that one. So this can make the sequence a bit more rhythmic. Now this is not exactly a clock divider, but it's working kinda like a clock divider. Pretty useful feature. And lastly, you also have this length control. So instead of repeating those steps, it does a little legato thing. Now while this trigger is working on the envelope on the filter cutoff, we can also make the step sequencer modulate the filter cutoff. I'll choose S4. And let's set S4 to random. So now we're getting a pretty complex step sequencer pattern. So those are the main ways you can use the sequencer. The sequencer also has additional outputs here for each column, so you can modulate other parameters with this. So for example, I can take this output here and modulate the pulse width. Maybe I'll take another one and modulate the filter resonance. Well, this filter does not have an option for that, so I can't do that. But you get the idea. You have 4 different outputs here, so 4 different parameters can be modulated. Maybe let's try this amplitude modulation input on our VCA. Add some smoothing. Change up the rate. You can also control the sequencer rate with an input here. So maybe I'll take this sine LFO out and plug it into the sequencer FM input. Let's speed up that LFO. Now we're not hearing any change because we haven't set up the depth control. And now you can hear the sequencer rate is going crazy. I didn't talk about this switch here, but it's pretty straightforward. If you want your sequencer to play forward or forward and backwards, you can switch between these 2 modes here. So that's the very cool, very powerful Moog Modular V sequencer. Now, other than the main 2 VCAs over here, you get 16 additional VCAs at the bottom over here. Now, out of these 16, the last 4 have a linear response, while the rest have exponential responses. So it's best to use the last 4 when you're working with control voltage, and the others when you're working with audio rate signal. Now, how can we use these? At the simplest, it can just be like a volume control for anything that does not have a volume control. I'll take the square wave out from this oscillator and plug it into the input on the VCA. I'll take the output from there into the filter and the out on the filter to the main VCA. I'll crank up the sustain on this ADSR. That was too loud. As you can see, the volume is cranked up to the maximum. Let's bring that down. So now we have volume control over the oscillator signal that's going into the filter. So if I crank up the gain here, I'm feeding the filter a hotter signal. That'll definitely change up the tone. There's also a little soft clip option which we can enable. So all that makes this VCA pretty helpful. And you also get an amplitude modulation input here. So I can take the sine output out of this LFO and plug it into the amplitude modulation in on this VCA. Increase the depth. Be careful with that control as there's a 12 dB headroom on this VCA. So it can be quite handy if you want to add some gain to any signal that's a bit weak. So now we're getting amplitude modulation on this signal that's going in to the filter. So you get 16 of these, and you can also chain a bunch of them together. So for example, if I bring in another signal, let's say I'll take the sawtooth out and bring it into the second VCA input. Now by default, that second VCA has its own independent output. But we can turn on link over here. So now, the second VCA signal is going to go out on the VCA1 output. And you can hear that second oscillator. So with link off, you just get that one oscillator signal. But if I turn on link, we're hearing both those signals. Now the second signal still has its own volume control, so you have control over its level, but the output is still going out of VCA1. So like this, we can chain a whole bunch of different outputs together. Since we have 9 oscillators, let's try chaining a few of them together. I'll bring in a third one on this third VCA's input, turn on link. Let's turn on the soft clip, just in case it's a bit too loud. So now we have 3 separate oscillators together going into that filter. Let's bring in one more, the pulse output here, into the fourth VCA. Turn on link, as well as soft clipping. I'm not sure if you're hearing that fourth oscillator. Let's bring down the level on some of these other ones. I'm hearing something, but we're not quite getting the clean oscillator tone. Found the culprit. It was the pulse width control. Cool. Now we're hearing 4 oscillators together. Let's add one more. Maybe the pink noise signal. I'll turn on soft clip as well as the link feature. So now we have some noise layered in with those 4 oscillator signals. Now, as I mentioned earlier, these last 4 VCAs are linear, meaning they work best for control voltages or anything that's not running at audio rate. So let's take this sine LFO out, plug that into this VCA. So that signal comes out there. I'll take this sawtooth LFO output and plug that into the VCA input here. And now we can link these two. So the combined output will come out of this VCA out, and let's plug that to the filter cutoff modulation in. So you can use the VCAs like this to combine different control signals into one, which then in turn can be used to modulate different parameters. So you can create some new interesting shapes by combining multiple LFO shapes like this. Alright, so that's the mixer section that's built into the bottom area of this oscillator section. We've looked at the filter in the Essentials course. So if you watch that, you already know that you can click on the name of the filter and you can change out the filter type. But you can also click over here and swap out the entire module. We have a few different options here. Let's check out the formant filter. So a formant filter basically creates those vowel-y type sounds. Let's have a listen to it. I'll take the pulse out of this oscillator and plug it into the input on the filter. And take the output and plug that to the VCA in. I've already set up a sequence on the step sequencer, lane 1 specifically. It's running at a moderately fast rate, and that's going to control the pitch of our oscillator. So this is the formant sound. It's basically a bunch of different bandpass filters in series. So that's the first, second, third, and fourth filter. You also get these preset settings for the filter that will mimic certain vowels. So you get all the different vowels there. Now when you choose a particular vowel preset, the dials on the filter will not update to show the current settings of that preset. But it definitely is changing it. Let's test this. Let's look at mod 4 over here. So if I just touch any of these parameters, so it didn't change much there, but let's try mod 3. And now you can hear it sounds a bit different. Let's try mod 2. So that's a very drastic change there. And the reason this is happening is because the preset probably has these parameters set to a different value. So let's try this. I'll move this parameter all the way down. So it sounds kind of thin. And let's switch out that preset and go back to A. It sounds nice and bright. Now as soon as I touch that parameter, you can hear it snapping to this new value, which is not what the preset has it set at. Now ideally it would be perfect if the parameters update when you change the vowel preset, but it doesn't, so just be aware of that. Alright, now let's talk about the actual parameters. So the first one is your filter frequency control. The next one is resonance. And the last one is gain. And all the 4 sets are identical. You also get CV modulation inputs for all the 3 parameters, and a modulation in to control the global frequency cutoff. Let's get some modulation going. I'll take the sine wave LFO and plug it into the frequency on the mod 2. I'll take the sawtooth from that same LFO and plug it into the mod 4, frequency cutoff that is. Let's make use of some of the step sequencer outputs. Let's plug that to mod 1, frequency cutoff. Let's take column 2 to modulate the frequency on mod 3. I haven't made any changes on column 2, so let me quickly just change up those control voltage values. Let's take column 3 to modulate the resonance on mod 3 here. We can globally modulate the resulting vowel by plugging in a control voltage signal in here. On this other LFO, let's take the triangle out and use that to modulate that vowel. Now you can hear it's very dramatic. So for a more subtle change, you may want to modulate the individual Mod 1, Mod 2, Mod 3 and Mod 4 parameters. But for this very dramatic kind of a change, go for that global modulation input. So that's the Foreman filter. Now let's check out the Bode shifter. So in the same menu, I can swap out the Foreman filter with the Bode shifter. So the Bode shifter is basically a frequency shifter inspired by the original Harold Bode design. Let's see it in action. I'll take a sine wave oscillator out and plug it into the input on the frequency shifter. Now our frequency shifter will produce the sum and difference of the two signals involved, the two signals being the incoming signal and the internal sine wave on the shifter. So with this mix, you can hear the sum and difference together, or you can hear the individual outputs from this A and B output. I'll plug the mix out to the VCA input. Now with the mix style, we can actually blend between the two A and B signals. So when it's on the left, it's just signal A, and when it's on the right, it's signal B. I'll set it in the center so we hear both. So let's talk about the amount of shift dial. Now a frequency shifter shifts all the frequency content of the incoming signal in a linear way, either up or down, compared to a pitch shifter, which transposes the frequency content in the sound up or down exponentially. So that maintains the harmonic integrity of the sound, whereas a frequency shifter is just mathematically adding or subtracting to the existing frequencies in the sound. And this may result in an inharmonic tone. Now the scale dial has an option for exponential mode, so it can also act like a more traditional pitch shifter. Let's listen to it. So we're still hearing the sum and difference. So that's why you're hearing two different sine waves in that tone there. But it's definitely working exponentially. So you can still get harmonically pleasing results with this. Now all the other scale modes are linear. Let's try the first, where the dial range is set to 5 Hz up or down. I'll double-click the amount of shift dial to set it to the center so there's no shift at all. But as I increase it, you start to hear that shift. And as I go into the negative, again you hear that same shift, but phase inverted. Now we can always choose to just listen to the sum or just listen to the difference by choosing either output A or B, but with the mix, we get to hear both simultaneously. So that's just a 5 Hz range. Let's try 50. Next, it goes up to a range of 500 Hz. Now you notice something interesting happening there. As it goes lower and the pitch reaches the lowest frequency, and then we go further down, the pitch starts to go back up again. So it's kind of like that through zero modulation. So once the signal goes below 0 Hz, it gets inverted and becomes a positive signal again. Alright, finally you get the 5000 Hz range. Now I have a sequence set up. Let's hear it with that. Pretty cool. But the thing is, we're using sine waves, so the result is just one sum and one difference. But if you use a complex waveform, we have many more frequencies in it, like for example a pulse. So there's going to be much more sums and differences, and we're going to get a much more inharmonic result. So again, right in the center, no modulation. But as I move that dial, now you can hear a much more complex and inharmonic tone overall. And again, with the mix style, we can choose to listen to the sum or the difference. It kind of has a bit crushed or down sampling type effect. Pretty cool stuff. Let's reduce that range a bit. Now, of course, we can externally modulate that amount of shift control. You get 3 modulators for this. So let's just take a simple sine LFO and plug that in. And you can hear that being modulated. At these lower rates, you get these pretty cool amplitude modulation style effects. Alright, so that's basically how the bode frequency shifter works, mainly used for creating rich and inharmonic tones. Now, just like how we can swap out any of these filter modules with any of these other modules here, you can do the same on this right side. So for example, any of these envelopes can be swapped out by clicking on the name of the module and replacing it with any of these other modules. Let's check out the ring modulator. The ring modulator is very similar to the frequency shifter. You still get the sum and difference of the two signals. The main difference being you do not hear any of the original signal, whereas in the bode frequency shifter, you do hear the original signals. Let's hear this in action. I'll take a sawtooth oscillator and plug that to the input on the frequency shifter, and let's take the output and plug it into the VCA input. Now you do need 2 signals for the ring modulator to work. We can plug in a second signal over here, but if you don't plug in a signal here, there's an internal sine wave that the ring modulator will use to multiply with the incoming signal. So we can still get those sums and differences. This dial sets the frequency of that internal sine wave, and this dial sets the depth of that modulation effect. Both the dials can be modulated with their respective modulation CV inputs. Alright, so let's have a listen to this. So if the depth is all the way down, it sounds like this. Clean. And if we gradually bring in that ring modulation, so we're getting that same dissonant inharmonic tone, but you'll notice that the original signal is completely removed. We're only hearing the sums and differences. This actually makes it sound even more dissonant when compared to the bode frequency shifter. Just like the frequency shifter, at a very slow rate, you get that amplitude modulation style effect. Okay, now instead of using that internal sine wave signal, we can use another external signal. For example, let's try this LFO signal. So now we've replaced that internal audio rate sine wave with this external low-frequency sine wave. So the result is your more traditional amplitude modulation. There's a high quality button there, so you can just turn that on for a better ring modulation result. Technically, this is not ring modulation, as both the signals need to be running at audio rate. So let's swap this out with an audio rate oscillator. I'll make sure it's set to an audio rate here. And you'll notice when I change the frequency on one of the signals, we get a very dissonant tone. So as you can tell, you can get a better result or a more harmonic result by setting the oscillator's tuning to a more musical interval. Usually unison or octaves work best. A fifth will also work pretty well. Anything aside from that can sound quite dissonant. Let's try modulating these two controls here. I'll take the sine wave here and use that to modulate the modulator's frequency. So we'll unplug this signal. And now we're back to using that internal sine wave. And let's use this LFO to modulate the depth. Let's try this with a sequence. I didn't patch the depth modulation, so let's try that again. As you can tell, you can get some pretty wacky results with this. So that's the ring modulator. The trigger delay can be used to delay the onset of envelopes or even the sequencer. Let's try it out with the envelopes. I'll take this envelope out and plug it into the modulation input on this filter. I already have a pulse oscillator going into the filter, which is then going into the VCA. So right now, the modulation happens instantaneously. But we can delay this. Instead of triggering this envelope with the keyboard trigger on, we can trigger this with the trigger delay 1. You can set up 2 separate delays with this one module. This dial sets the delay time for that first delay, and you have a trigger input to set when you want to trigger that delay. So let's set this to the keyboard trigger on, so when I play a note, the delay gets triggered, and then after about 500 milliseconds, the envelope will get triggered. And that's exactly what's happening. Shortening that delay time can give you this cool doubling type effect. Now we have a second one here. Let's use another envelope on that same filter cutoff modulation. Let's give this envelope some decay time. And let's trigger this with the trigger delay 2. So now, Oh, we haven't set the trigger for this second delay. I'll set this also to keyboard trigger on. And now you can hear that second trigger. We could even set this to the keyboard trigger off. So when I release a note, it triggers the second delay. We'll have to add a bit more release on the amp envelope. Now we can hear that. If there was no release, you wouldn't hear the second trigger at all. Alright, so let's set this back to keyboard trigger on. Now right now these two trigger delays are independent, but we can link them. So if I set this to parallel, we can basically ignore the trigger input for the second one, as it's going to be triggered when that first delay is triggered. So in this example, it sounds pretty much the same. Then we get this serial mode, where the first one triggers, and then when it's done doing its thing, the second one initiates its trigger. So you can hear it takes a bit longer to hear that second trigger. A bit longer there. So that's your trigger delay, and some use case examples with the envelopes. Now let's check out the sample and hold module. Here we have two of those, they're both identical. I'll load in one. So a sample and hold module samples an incoming signal and then holds that particular value until it samples it again. Usually the rate of sampling is slow, which makes the hold time particularly obvious. So let's see it in action. The most obvious use for this is to sample a slow-moving signal like an LFO. So I'll take the sine out and plug it into the input on the sample and hold. And we can take the output of that and plug it into the frequency modulation input on the audible oscillator. So now this sample and hold signal will be modulating the pitch of the oscillator. Let's take the output of that oscillator and plug it into the VCA. Okay, so right now it doesn't sound any different from a regular LFO modulating pitch, a sine wave LFO modulating pitch. That's because this glide parameter is up, so let's bring it all the way down. We also have an option here to choose when the trigger happens, so we can just switch that on or externally trigger this, just like the envelopes. I'll just turn the trigger on. Now the last and most important parameter is the clock rate. This needs to be relatively slow in order to hear the sample and hold effect. Now you can hear that sine wave modulation sounds stepped. That's because we have a slow sampling rate. We can slow that down even more. So now it doesn't even sound like a sine wave modulator. But if that rate is really high, it goes back to being a regular sine wave. Very similar to actual audio sampling rate. If your sampling rate is high enough, you maintain the integrity of the original sound. But if it's reduced, you can distort the sound. And that's exactly what we're doing here. We're distorting that sine wave LFO by reducing its sampling rate. Now what if we add some glide to that? So I'll slow this down again, so you can hear it's clearly stepped. But if you add some glide, it's gliding between those steps. Now instead of a sine wave, we can try one of these different options on the LFO. Let's try the sawtooth. I'll get rid of the glide. So now it's stepped. And if the clock rate is too fast, it becomes smooth, like a pure sawtooth LFO. We can try the square wave option, but it's not going to give you much of a result. No movement at all there. Let's try the random signal. So now it's a random step shape. The most common way to use a sample and hold is to use it with a white noise signal. So let's take the white noise output and plug that into the input on the sample and hold module. And now we get this very typical random pitch modulation effect. I call this the bleeps and bloops modular patch. We can add some glide so it smoothens out the transition between those steps. Cool, so that's how the sample and hold module works. So now let's check out the envelope follower module. So I'll click on one of these envelopes here and swap it out with the envelope follower. You get 4 of them. So an envelope follower is a module that accepts an incoming audio signal, and then it will create a control signal based on the amplitude shape of that incoming audio signal. So you have some controls on detecting that incoming signal, like setting it to long or short. This works in conjunction with the time dial, and all this will basically set how the module will react to that incoming audio signal. There's an input for the signal and an output for the generated control signal. In addition to the envelope following, there's also a trigger output that can be generated. You can set a threshold for the trigger with a threshold dial, and this is where you input the signal for that trigger. So you have 2 separate inputs, one for the envelope and one for the trigger. So let's see how all this stuff works. So I have a drum beat coming into this external input here. We can listen to this. I'll plug it into the VCA, play a note. So we're going to be using this signal. So I'll plug that into the input on the envelope follower. And now let's use the contour out to modulate something. So I'll set up a regular voice, let's say the pulse oscillator going to the filter in, and the output of the filter going to the VCA in. And now we will modulate the filter cutoff with that envelope follower contour output. I'll set the depth to the maximum. And you can already hear the modulation working. Right now it's set to short. Let's play with the time parameter. If it's too short, it can sound a bit distorted because the module is trying to listen to every little nuance in amplitude change. If it's too long, then you barely hear any movement. We can switch to this long mode and reduce the time. That seems to be a good setting for this drum loop. Let's hear this along with the actual drum loop. Maybe I'll plug that into the second VCA in. Let's trigger this with the keyboard trigger on. Crank up the sustain. So now when I play a note, now you'll notice that even though we have set the modulation to maximum, we're not quite getting a really wide range. So the signal is a bit soft. So what we can do is make that incoming signal louder using the VCA before it goes into the envelope follower. So I'll plug it into this VCA in here. I'll take the output and plug that to the input on the envelope follower. Now we have a gain control, so we can make that signal louder. Another use for the VCA. Alright, so that's how the envelope following works. Now let's talk about that trigger generator. Now the trigger output is not directly available on the module. It does not come out of this contour output. So we can actually disconnect that. But first we need a signal coming into the contour in for the module to use as a detector signal. So I'll take that same drum beat signal coming out of this VCA and plug that into this contour in. Now it's going to create that trigger. Now, like I said, there is no trigger output on the module. This is just an indicator when that trigger threshold is reached. But you can access that trigger output from trigger menus like these. So let's set this envelope 1's trigger input to envelope follower trigger out 1. So whenever there's a trigger being generated, this envelope will trigger. And then we can take the output of that envelope and modulate the filter cutoff. You can see the LED lighting up there, so it is working. Maybe I'll reduce the depth a bit, and let's play with the threshold. So if the threshold is too high, we don't get that many triggers. If it's too low, we get a bit too many triggers. In fact, to make this even more plucky, we can make the main VCA amp ADSR trigger with this. We can do the same for this one as well. So even the drums has that gated effect. Cool, so that's the envelope follower module. So now let's take a look at the fixed filter bank. So unlike the filters we've looked at previously, nothing can be modulated on this fixed filter bank. That's why it's called fixed filter bank. So you get 12 different frequency bands, each set to a specific frequency range starting from 125 and going all the way up to 5600 Hz. It's actually quite easy to use this. You do not need to patch anything. You can just engage any of these two switches and the filter will be introduced into either of the two VCAs. There's an overall gain control and a reset switch to reset all the parameters back to default. There's a low-pass filter on the signal before it goes through the fixed filter bank, and then there's a high-pass on the outgoing signal. Each band has a gain control as well as a bandwidth or quality control. So let's have a listen to this. I have a patch already set up. So there are two different signals going to the two different VCAs. Let's engage the fixed filter bank on VCA 1. So right now we're hearing VCA 2 clean and VCA 1 filtered through the fixed filter bank. Be careful with that gain control. You want to avoid clipping. So you want to look in your DAW and make sure the meter is not going into the red. There's also a master volume control here that you can bring down if it gets too loud. So now I can adjust the gain on the different bands as well as the bandwidth. Now it is a bit hard to hear exactly what's happening because VCA 2 is kind of masking this. So let's engage VCA 2 as well. So now both the VCAs are being filtered by the fixed filter bank. And now we can really hear how each filter works. The overall gain control helps a lot. When you filter things too much, you can crank up the level with that gain control. So there you go, that's the fixed filter bank. Pretty straightforward. Just engage the switch on the VCA you want the fixed filter bank to affect and tweak the parameters. Let's now check out the dual delay. So similar to the fixed filter bank, no modulation options, so no patching required. Just have the two switches for each of the VCAs to engage the delay on either of the two VCAs. Let's set up a quick patch. I'll take a pulse going into the filter and the filter out to the VCA 1. Now instead of triggering this with the keyboard, let's trigger this with the sequencer trigger. So let's set up a quick sequence. I'll just use this first lane. So select S1 here in the oscillator section. I'll speed up the rate of the sequencer. So now we get this nice plucky sound. And that's because the sequencer trigger is triggering the VCA. So now let's engage the delay on this. Crank up the time. So as you can see, it's a stereo delay. You get two independent left and right delay time control, dry and wet control, left and right independent feedback controls. There's also cross feedback. So some of that left signal going into the right and the right signal going into the left. We can also sync the tempo to the project BPM. And now your time shows musical subdivisions of the bar. Let's open up that filter a bit. So pretty straightforward, nothing too fancy about it. Now one interesting use of this is to create stereo width on your signal. So let's try that. I'll turn off MIDI sync, bring the left delay time all the way to the lowest, and the right delay time can be just a few milliseconds up, so approximately 10. No feedback on either of the two channels. Wet all the way up and dry all the way down. I'll also bring down that main feedback. So now if we listen to this, you get this nice stereo effect. It's a bit too loud. Bring down the volume on the VCA. So with it off, it is softer, but it's also very mono. But with it on, it's louder and also very stereo. So that's the dual delay effect. For the last effect here, let's check out the chorus module. Again, very simple, no modulation options, but the two switches to engage the chorus on the two VCAs. You get three chorus types. You have to click and drag sideways. So there's simple, middle, and complex. There's the chorus rate control, delay time control, overall amount, stereo width modulation rate, stereo width amount, and dry wet controls. Let's have a listen to this. So we'll engage this on VCA1. So you can hear the modulation is a bit too excessive. So we can slow that down and also tone it down. Reduce the delay time. Now it sounds a bit more like a regular chorus. It can sound pretty interesting in polyphonic mode, so let's switch this patch to polyphonic mode. Increase the number of voices. Add some release to my VCA. Let's try some of the other chorus types. It's got a bit of a flanger type vibe. Let's try the complex one. This definitely has that flange tonality. It can take some time to tone down some of these controls and get a more natural chorusing effect. But I think we're there. That sounds pretty nice. So there you go, that's the chorus module. Let's now talk about the LFO mode you get in the keyboard tracking options in the oscillator driver section. So you know that you get 4 keyboard tracking options. You can also turn it off. And then there's this LFO mode. So let's talk about this LFO mode. I have this simple one voice patch setup. Let's switch this to polyphonic mode. So choose poly here. And I'll increase the number of voices. Alright, so now I want to use one of the other oscillators to modulate the pitch of this audible oscillator that we're using. So let's take the sine wave out of the 4th oscillator and plug it into the FM input on this oscillator. I'll crank up the depth. Let's set it to a low rate so it acts like an LFO. Now if keyboard tracking was on, for example if this was set to K1, so that modulation will not have the same rate across the entire keyboard. Okay, first let me just make this a bit faster. I'll switch it to octave mode. Okay, so I'm playing a middle C right now. Now if I play a C octave above that, you can hear the rate is faster. If I play an octave below, you can hear it slower. So that LFO is being key tracked. If I turn off key tracking, now it's going to be consistent across the entire keyboard. So we get the same rate modulation on every note. But I'm in polyphonic mode right now, so I can play multiple notes. So you can hear every note gets its own independent LFO, and that can sound a bit messy, especially when the notes are not played simultaneously. So for a more consistent sound, we can switch to LFO mode. So now all the voices will get the same phase LFO modulation. So you can hear that all the notes get that same modulation. So that's basically the purpose of that LFO mode. Let's now look at this keyboard controllers section. It's pretty simple and straightforward. So you have your pitch bend range control. This sets the range of your pitch bend wheel. The value you set here is the same for pitch bend up as well as down. Right now it's set to 1 semitone, but I can crank it up. It goes all the way up to 4 octaves. So a pretty wide range for this. Let's try 2 octaves. So now when I play a note, I can pitch bend that up 2 octaves as well as down 2 octaves. You can't disable it completely here. The lowest you can set it to is 1 semitone. Now you can also make the filter cutoff react to this pitch bend. So if I crank this up, now when I play around with the pitch bend wheel, the filter cutoff is also opening and closing. Pretty cool. Next, there's your voicings option. By default, it's set to mono, but you can also set to unison and set the number of unison voices. And then there's a voice detune control here. You can only play monophonic in this mode, but you can switch to polyphonic mode and play multiple notes simultaneously. And of course, as you know, these features were not there on the original hardware. Next, there's a retrigger and legato option. Let's talk about the legato first. It's related to the glide control here. So if I turn on glide and give it some glide time, and now you can hear the notes gliding. we're in polyphonic mode, so it works a bit different here. Let's switch to monophonic. Let's try this again. So legato is off right now. You can hear that glide happening irrespective of if I'm playing legato or separated notes. But if I turn on legato, that glide only triggers if I play legato. No glide there. And now we get glide. So that's how that legato switch works. Let's turn glide off. And now let's talk about retrigger. It refers to how the envelopes work. So let's set up an envelope to modulate the filter cutoff on this filter. I'll increase the depth of modulation. So you can hear that modulation now. So if retrigger was off, if I play legato, you notice that the envelope does not retrigger. But if I turn on retrigger, the envelope retriggers on the start of every new note. So that's it. That's the keyboard controllers section. In the Essentials course, we did go over key follow, but we didn't go into much detail. So let's check this out here. I load in a new patch, go into the templates, and load this one oscillator, one filter preset. So by default, our main oscillator over here, or its driver, is set to K1. So it's following keyboard follow 1 settings. So as we already know, keyboard follow sets how the oscillator reacts to the different voltages coming out of the keyboard. So right now the slope is set to 1, so you get that equal tempered tuning. I can reduce that or increase it. So you can get some pretty interesting tunings with this. But you already knew that. Let's check out some of the other controls here. There's a key shift option which sets your center point or the center note. Over here C3 is the center point, so nothing shifts on C3, but all the notes above and below will get shifted. So you can change that center note. So let's say I'll set it to G3. So when I move that slope dial now, nothing changes on G3, but higher notes you can hear get transposed up and lower notes get transposed lower. Alright, so that's key shift. Next is the threshold. The threshold defines when this key follow triggers. So when it's set to C-2, basically any notes above C-2 will trigger that key follow. Or in other words, any notes above C-2 will follow the settings of this key follow. So let's say if I change that to F3, so any notes below F3 will not have any key follow, and notes above F3 will have the key follow. So that's your threshold. You generally want to set that to the lowest note. Now, other than just controlling the pitch of your oscillator or the cutoff on the filter, this key follow also generates a trigger signal. And you can set a specific key range for that trigger to happen. So if I set a range here, let's say E3 to, let's say F4. So now any notes that fall within that range will generate that trigger signal. So let's test it out. Let's set up our usual example of envelope modulating the filter cutoff. Increase the depth, reduce the filter cutoff. So now that envelope triggers every time I play a new note, because the trigger for this envelope is set to keyboard trigger on, but let's switch that to keyboard follow trigger 1. So now, if the notes I play fall within this range of E3 to F4, only then that envelope will trigger. So you notice if I play lower notes, the envelope does not trigger, but within that range, the envelope triggers. Up to F here, it triggers the envelope, but higher notes don't trigger that envelope. So that's pretty cool how you can set up things to trigger on specific keys. Or you can set that range to the entire range of the keyboard, so that trigger will happen on every note. So that's this section over here. Now, aside from the slope and trigger options for each key follow preset, you also have a pitch bend control. So right now it's on, meaning the pitch bend wheel will work. Let's open up that filter cutoff a bit more. So this is just how it works. But I can invert this. So now when the pitch bend wheel goes up, the note goes down, and vice versa. Now that's for any drivers set to this keyboard follow. But we can set up multiple key follows since we have 4 of them. So let's bring in a second oscillator. So I'll take the pulse out of this oscillator. Let's plug it into one of the inputs on this mixer here. I'll enable link. So now we have 2 oscillators combined going into that filter. I'll make sure the pitch is set to an audible range. Open up the pulse width. So now, actually, we need to go back and ensure that that second driver is set to K2. So now when I pitch bend up, so you can hear one oscillator pitch up and the other oscillator pitch down. You can also create interesting harmonies by playing around with that key shift. Cool. So that's for pitch bend. You also have a portamento control here. So right now it's set to portamento mode. But you can also set it to glissando mode. So the portamento time actually changes depending on the distance between the 2 notes. Or you can completely turn it off. So now one oscillator has glide and the other does not have any glide. So those are all the settings on the key follow. With that, we have come to the end of this course. We've looked at a lot of advanced features that should complement what we looked at in the earlier Essentials course. The Moog Modular V is no doubt a very powerful synthesizer. As you have seen over the duration of these 2 courses, there's so much stuff you can do with this. Alright, I hope you have fun with this, and I'll see you in the next one.